So today we're just going to do kind of an introduction to different angles, different kinds of arcs. There's not an assignment for this one just because it's an introductory one. I just want you to be familiar with all these because they're going to pop up a lot in these next few sections, and so I just want to make sure that we have a really good understanding of what they are so that we are able to move forward with some of these newer sections. So the MDI today is finding the area of the regular polygon again. So just like we've been doing, let's set up that formula first. So remember that S represents side length, A represents the apothem, N represents the number of sides. Remember that the apothem has to be perpendicular to a side. It cannot go to a corner of the polygon. So if we look at the segment that is drawn in this polygon, the segment goes to a corner. So we know that that is not the apothem, which means that we are going to have to find the apothem to calculate the area. So we just want to draw in our apothem like we've been doing. This is our apothem right here. The 9, remember, represents the hypotenuse of this triangle. So what we want to do is we want to start filling in pieces here that we know. We know that N in this case is 6. The apothem is what we need to find. We know that S we can find by taking perimeter divided by the number of sides, which in this case is 10. So we know that this whole side length right here is 10. But in order to find the apothem, we only need this piece right here because remember, we're going to set up this right triangle. So this right here is 5. So now we have our new right triangle. This is 9, this is A, this is 5. Here's our right angle. Remember that if you turn this into an arrow, this arrow points right at your hypotenuse, which always has to be C in the Pythagorean theorem. So we can do a squared plus 5 squared is equal to 81. Sorry, we'll do 9 squared. Jumping ahead of myself. 9 squared. So a squared plus 25 is equal to now 81. Subtract the 25 from both sides. So a squared is equal to 56. And if we take the square root of 56, we get 7.48, which we are going to round up to 7.5. So there's the last piece that we need to find the area, so we plug this in. So if we take 0.5 times 10 times 7.5 times 6, we get 225, which is the area of this whole polygon. Okay. Today what we want to be able to do is understand the difference between central angles and inscribed angles, and we want to be able to find intercepted arcs for each. We also want to go the opposite direction. If we're given an intercepted arc, we want to be able to find either the central or inscribed angle that goes along with that intercepted arc. So the first thing that we need to do is we need to define what is an arc. So an arc is just an outside portion of the circle. It's just a portion of the circumference. So an arc can look like any length. This would be an arc right here. This would be an arc right here. This would be an arc right here. So it's any outside portion of the circle, and it's just a portion of the circumference. A central angle is an angle whose vertex, so let's underline this because we want to talk about that in a second, whose vertex is the center of the circle. So vertex, remember, just means the corner. So if you're looking at an angle, this right here would be the vertex. So remember, to name an angle, we need 3 letters, and the middle letter has to be where the vertex is located. So if we think about angle CPA, CPA is this angle right here, this angle right here. So the vertex is at P. Since the vertex is at the center of the circle, then that means that this is a central angle. And the same goes for angle CPB. So angle CPB is this angle right here. And again, its vertex is also the center of the circle, so that is also a central angle. Okay, just like we have different classifications for angles based on their measures, we also have different classifications for arcs based on their measures. So the first kind of arc that we're going to talk about is a semicircle. So a diameter, remember a diameter goes all the way across the circle, so this is the diameter here. A diameter cuts a circle into two semicircles. So a semicircle is equal to 180 degrees. When we name a semicircle, we use 3 letters, and each one of those letters has a specific job. So the first letter tells us where to start our semicircle. The second letter tells us what direction we're going to move in, and the third letter tells us when we're going to stop. So this semicircle goes from T, moves to R, and stops at S. So this is our semicircle that we're talking about. In some cases, you will see a semicircle written with just 2 letters because this semicircle and this semicircle are going to be equal. So sometimes it doesn't matter which semicircle we talk about. The second kind of arc that we're going to talk about is when you have a minor arc. So a minor arc is less than 180 degrees. So if you were to draw the diameter through here again, you can see that this this arc right here is less than a semicircle. So it's going to be less than 180 degrees. And RS just gives you the starting and the end points. It gives you the 2 end points for this arc. So in this case, our arc starts at R, and then it goes until S. And we know that it's not going to go in this direction because it has to be less. There's only 2 letters, so we know that it's a minor arc. It has to be less than a semicircle. And we'll get to this part later, so it's not important that we talk about this right now. But the third arc that we want to talk about is a major arc. So a major arc is, and again, we're not going to talk about this right now, a major arc is greater than 180 degrees. So again, if we were to draw the diameter in here, we can see that this arc, just like the 3 letters here, these 3 letters tell us this arc starts at R, we move towards T, and we don't stop until we get to S. So this arc right here is what we're talking about. So you can see that this arc is greater than half of the circle. Okay, so a major arc is greater than 180 degrees, and we use 3 letters always to represent a major arc. So the next thing we're going to talk about is a central angle, which we talked a little bit about on the previous page. A central angle has a vertex at the center of the circle. So you can see that the vertex of this angle right here is B, which is the center of the circle. We have this new vocab down here, intercepted arc. And an intercepted arc is just an arc that's interior to the sides of the angle. So what you can think about is if you find the vertex and you follow this vertex out to where it touches the circle, you can see that the intercepted arc is going to be in between those 2 sides. So it's got to be in between those 2 sides. So our intercepted arc here would be arc AC, and we're only using 2 letters because this is a minor arc. It's less than half of the circle. If we were to draw in the diameter here, you can see that it would be less than 180 degrees. We could also name this arc, CA, because just like a line segment, reversing these 2 letters tells us the same thing. All right, we also have an inscribed angle. So an angle is where the vertex is on the outer edge of the circle. An inscribed angle is when the vertex is on the outer edge of the circle. So if we were to look at this angle, we see that its vertex is all the way down here on the edge of the circle. But we still have that inscribed arc. So if we are to follow this from the vertex, follow these sides out to where it touches the opposite side of the circle, we can see that the intercepted arc is this arc QS, or if you wanted to call it SQ. So on this one, we can see that the vertex here, so this angle is the angle in green, and we can see that the intercepted arc, we can see that the vertex is on the circle, which means that this angle right here, angle ABC, is an inscribed angle. And its intercepted arc is arc, so if we follow this out, follow the sides, it's the arc in between those two sides. So our arc would be AC. And we don't use D. The only reason that D is there is to throw you off. So we just use AC because, again, if we were to do a semicircle, this would be less than the semicircle. So the intercepted arc would just be AC. Okay? On this next angle, we can see that the vertex of this angle that's highlighted in green, the vertex is at the center of the circle. So this angle, angle ACB, is a central angle. And its intercepted arc, so again, if we follow these out, we can see that the intercepted arc is between those two sides, which is AB. Again, vertex is at the center of the circle, so this is a central angle. Vertex is on the circle, so this is an inscribed angle. All right, next thing we want to do is we want to be able to determine from a picture that has a little bit more complication to it, we want to still be able to name a central angle and intercepted arcs and inscribed angles and intercepted arcs. So if we know that we're talking about a central angle, we know that the vertex of that angle has to be the center of the circle. So if we can find any angle whose vertex is at the center, then that would be a central angle. So if we look, we can see that COE is a central angle, and if we look, we can see that this right here would be the intercepted arc. We can also see that angle EOB would be a central angle, and again, if we look at the arc that's in between those two sides, is this right here, so we know that arc EB is the intercepted arc for that. You can also see that COD, DOA, and AOB are all central angles, in addition to DOB, COB, EOD. There's lots and lots of different central angles here. The inscribed angles, remember that we have to have a vertex on the circle. So if we look around, we can see that there are some points that are on the edge of the circle here. So these would be where all the vertices of the inscribed angles would be. So we could say, for example, that BCD would be an inscribed angle, angle BCD. And the intercepted arc for this, if we look at where the two sides come out, it has to be the arc in between those. So this arc right here, BD, or DB, would be our intercepted arc. We also have, we could have a vertex at D, so we could say CDA is an intercepted arc, or I'm sorry, is an inscribed angle, so angle CDB. And we have to be careful in this intercepted arc because this arc goes all the way from C around the circle and all the way over to A. Now this is greater than half of the circle, so that means that this is a major arc, and we have major arcs, we need to make sure that we name those with 3 letters. So this would be either CEA, it could be CBA, or you could reverse it and go the opposite direction. So CBA would be one name for that major arc.